Okay, so my recommendation is that you try the warm-up on your own. So go ahead and turn this off, try the warm-up, and then come back and I'll show you what I did. So it says write the equation of the asymptotes. So what I would do is the center is -1, 3. This is hard to write on. And the slope of the asymptotes is going to be plus or minus 8 over 4. So 8/4, which is plus or minus, this is terrible, plus or minus 2. So I would get y minus 3 equals plus or minus 2 times x plus 1. And those would be the equations of the asymptotes. For the next problem, it says write the equation of the convex section in standard form. So it's a parabola, and I know that the center, it's a hyperbola. The center is 0, 2. So, and I know the x squared is going to be first because we're opening left and right. We're opening along, we're touching the x-axis. So we get x squared, and then it's going to be minus y minus 2 squared. And then we look here, the up from the center, we go 2 up. So the y's are going to be over 4. And then we go 1, 2, 3 to the left. No, something looks wrong. Oh, 1, 2, 3, 4, 5 to the left and right, so that would be 25 equals, and it's always equal to 1 just as the ellipse is. So, okay, so for problem 1, you can see this is a hyperbola because the squared terms, there's an x squared and a y squared, and they have different signs. So the problem is this is in general form, and we need it to be in standard form in order to graph it. So we've done this before with ellipses. We're going to complete the square, so I'm going to put the x's together. So I have 9x squared, whoops, and 9x squared minus 18x, and I have negative 4y squared minus 16y equals 43. So now what I'm going to do is I'm going to factor out a 9. So 9 times x squared minus 2x. So this is just like we did with the ellipse. Half of negative 2 is negative 1. Squared would be positive 1. The difference is now we're just factoring out a negative 4. So y squared minus 4y, and then half of that squared would be 4 equals 43. But I actually added 9 and I added negative 16. So now I have 9 times x minus 1 squared minus 4 times y plus, oh, this should be plus 4y, sorry about that. So this should be plus 2 quantity squared equals 43 plus 9 minus 16, so that's 36. Then we have to have, for standard form, we have to divide by 36 so that we get it equal to 1. So divided by 36, divided by 36, and our equation for our hyperbola becomes x minus 1 squared divided by 4 minus y plus 2 squared divided by 9 equals 1. And so to graph this, our center is 1, negative 2. So we'll plot that, 1, negative 2. And then Oops, just kidding. This should be over here. 1, -2. I said 1, -2. 1, -2, and then it's going to be opening left and right because the x squared is first. So I'm going to go 2 to the right and plot a point. And then I'm going to go 2 to the left and plot a point. And then I'm going to go up 3. And I'm going to go, whoops, down 3. And then if we just draw in, oh my goodness, draw in our box, it's going to look something, this is awful, something like that. And so we draw our asymptotes, and then this has to approach the asymptotes, and it's going to be in the x direction, just like that. Not quite just like that, but anyway, so our vertices would be, let's see, our vertices would be 1, 2, 3, so 3, -2, and -1, -2. And what I'm going to do is I'm also going to post on Haiku my key, which is much nicer than this, but at least I'm walking through this with you. All right, so on to the next problem. So on this one, I'm going to let you go ahead and do this one. So go ahead and do this one on your own, fill in the blank, and then actually solve this problem. So, and then turn off the recording and work on that. This is an ellipse. I'm just going to give you the final answer for the ellipse. Your final equation should be x minus 1 squared over 25 plus y plus 3 squared over 4 equals 1. So go ahead and graph that. And then the example 3 is another hyperbola. So why don't you try this one on your own? Go ahead and turn off the recording. Try this one on your own and then turn it back on, and you can see my solution, hopefully. So what I would do is 4 times x squared plus 8x, and then minus 9 times y squared plus 6y, this is a mess, equals 53. So then I would add 16, but it's not really 16, it's 64. And then here I would add 9, but it's not really 9, I'm subtracting 81. So now I get 4 times x plus 4 squared minus 9 times y plus 3 squared equals 36. So again, I'm going to divide everything by 36. And I'm going to end up with x plus 4 squared over 9 minus 9, just kidding, minus y plus 3 squared over 4 equals 1. Just kidding again. I keep doing that. This, okay, this, because I factored out a -9, so be careful, don't make the same mistake as me. That should be a negative, that should be a negative, and that should be a negative. So, and your vertices will end up being, and again, I'll post my nice worked out solution for you, -7, 3, and -1, 3. And then obviously you'd have to list the domain and range. And again, this is going to open left and right. Okay, so now we're going to get into some interesting problems, little different. So write the equation of the hyperbola with vertices of -3, -4, and -3, 8. So often what I'll do, which you see me do in class as well, is I'm going to plot this negative 3, 2, 3, whoops, oh my goodness. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8. So negative 3, 8, and negative 3, negative 4. This is just obviously a quick sketch. And it says whose asymptotes are y equals 6/5 x plus 28/5. So, in order to write the equation of the hyperbola, we obviously need to know the center. Well, if these are the vertices, that means my hyperbola is going to open up and down. And so what I'd like to do is find what the center is. So I'm going to find the midpoint of the y-coordinates, so I can find the y-coordinate of the center. And obviously I know the x-coordinate has to be negative 3. So I get 4 divided by 2, so I get the y-coordinate of the center. So the center is negative 3, 2. And because it's opening up and down, I know that this has to be y minus 2 squared. So the center, again, is negative 3, 2. Because it opens up and down, I know it's y minus 2 quantity squared plus minus x plus 3 quantity squared equals, and this all has to equal 1. So now I have to figure out what goes in the denominator. Well, as we discussed in class on day 7 yesterday, is that the slope is the square root of the denominators. So, and it's always y over x. So what goes underneath y is going to be 6 squared, which is 36. And what goes underneath the x is the 5 squared, which is 25. And that would be the equation of my hyperbola given that information. Okay, so moving on to the next problem. Let's go ahead. It says, write the equation of a hyperbola that opens left and right, has an asymptote of y equals negative 3/2 x minus 1/2, and one of its vertices is at 3, negative 2. Okay, so again, I think it's helpful to draw a picture just to get an idea of what this is going to look like. So let's look. It's opening left and right, so that means it's going like this, right? And the picture, so one of its vertices is at 3, negative 2. Okay, and it says it has an asymptote of y equals negative 3/2 x minus 1/2. So we know that the center has to lie on the asymptote, right? And we know that if this is a vertex, right, and it's opening, that means it's going to be like this, right, because it opens left and right. That means the y-coordinate of the center has to be negative 2. So what I can do to find the x-coordinate is I can say, oh, this, the center has to lie on the asymptote, and I know the y-coordinate is negative 2. So I'm just going to put negative 2 in to the equation of the asymptote. And if I multiply both sides by 2, I'd get negative 4 equals negative 3x minus 1. Now add 1, so negative 3 is negative 3x. So I get x is 1. So the center has to be at 1, negative 2. So we know it opens left and right, so we have to have x minus 1 quantity squared over something minus y plus 2 quantity squared over something. That has to equal 1. Well, if the slope is 3/2 or negative 3/2, under the y is 3 squared, so that would be 9. And under the x is 2 squared, and that would be 4. So this would be the equation of the hyperbola given that information. Excellent. Okay, let's keep going. Okay, last problem. So it says find the center, equations of the asymptotes, domain, and range. So first thing I'm going to do is notice the fact that the x squared is the negative quantity. So the y squared is going to go first. So I'm going to do 9 times y squared plus 4y. And then I'm going to do minus 4, I'm going to get it right this time, times x squared minus 6x. And that's going to equal the constant, which is 144, right? And then I'm going to take half of 4 and square it, so that becomes plus 4, but I didn't really add 4, I added 36. And then half of this squared, so that'd be plus 9, but I didn't really add 9, I subtracted 36. Oh, look, those cancel out. How nice. So now I get 9 times y plus 2 squared minus 4 times x minus 3 squared equals 144. So now I divide everything by 144. And it sure would be nice if those went in evenly, and they do. So y plus 2 squared over 9 times 16 is 144, minus x minus 3 squared over 36 equals 1. Okay, so the center, as for the center, so the center would be 3, negative 2. The vertices, oh no, equations of the asymptotes, that's all I ask, isn't it? So the equations of the asymptotes would be, let's see, I would do y, and then the center, so plus 2 equals the slope is going to be 4 over 6 times x minus 3, which then, of course, is, plus or minus. So the equations of the asymptotes would be y equals plus or minus 2/3 times x minus 3. And I'm just going to move up a little here. And so there are, you can write those, you can put them as 1 with the plus or minus. I asked for the center. And then the domain, so to figure out domain, I need to realize it's opening up and down. So that means my domain is going to be negative infinity to infinity. I don't know if you can picture that, because what's happening is it's going to be opening up and down. Actually, wait, I didn't want to do that. I just wanted to show you a quick sketch that if it's opening up and down like this, then our domain is going to be all possible x values. So negative infinity to infinity, our range has to be from negative infinity, and then it has to be to our vertices, right? So the vertices are going to be based off of from the center. So I like to figure out the vertices. So our vertices would be, the x coordinates are going to be 3. And then the y coordinates, the center's negative 2. So I'm going to add 4. And that's going to become, that's going to become, 2. And then 3. And then negative 2 minus 4 would be negative 6. So now the range would be negative infinity to negative 6, union 2 to infinity. So thank you for bearing with me. This is hard. I know my handwriting is not the best, but hopefully this will help. And again, I'm going to post on Haiku my keyed solutions so that you can also see a neater version of this. Thanks so much and have a great weekend, everyone. And don't forget your assignment is number 8 and that the test is on Thursday, May 8th. So you can be working on your review packet too. Have a great weekend. Bye.